Welcome to Edunovus practical session of focal length of a convex lens. In this session, we will determine the focal length of a convex lens by distant object method and UV method. Before going to the experiment, let us go through the terminology associated with the convex lens using a ray diagram.
Convex lens. It is also known as converging lens. It is thick in the middle and thin at edges. The diameter of the circular edge of the lens is called aperture. Here, AB is the aperture. When a ray of light passing through a particular point on the principal axis goes undeviated, this point is called optical center, and this is represented by O. First principal focus is a point on the principal axis of the lens. When a ray diverging from it after refracting from the lens go parallel to the principal axis. Here F1 is the first principal focus. Second principal focus is a point on the principal axis of the lens. When an incident ray parallel to the principal axis after refraction from the lens meet at this point. Here F2 is the second principal focus. The distance between the optical center O and one of the principal focus of the lens is called focal length.
Hope you got a clear picture about the terminology associated with the convex lens. Now, let us go through the aim and apparatus required to perform this experiment.
Aim: to determine the focal length of a convex lens. Apparatus: convex lens, optical bench, object, lens stand and screen.
Now, let me take you through the step-by-step procedure to perform the experiment. Here, first we determine the focal length of the convex lens by distant object method. So, take an optical bench and place the bench on a level surface. Then take a convex lens whose focal length is to be determined and place this lens on a V stand. After that, place the V stand on the optical bench at a convenient position. Here we need to place the lens in such a way that the lens is facing towards a distant object. Then take a screen and place the screen on the optical bench so that the lens is in between the screen and the distant object. Now we adjust the positions of the lens and the screen until we obtain a sharp image of the distant object on the screen. So, let us adjust the positions of the lens and screen. Here you can clearly see that a sharp image of the distant object is obtained on the screen. Now we measure the distance from the lens to the screen. Here the lens is at a position of 50.7 centimeters and the screen is at a position of 40.2 centimeters. Therefore, the focal length of the convex lens obtained by distant object method is 10.5 centimeters. Now, we will determine the focal length of the convex lens by UV method. Here, illuminated cross wires acts as an object. Place the object on the optical bench in such a way that the lens is in between the object and the screen. Now, we adjust the positions of the lens and the screen until we obtain a sharp image of the object on the screen. So, let us adjust the positions of lens and the screen. Here you can clearly see that sharp image of the object is obtained on the screen, and the distance from the lens to the object gives us u, and the distance from the lens to the image gives us v. So, let us measure the values of u and v. Here the object is at a position of 90 centimeters, lens is at a position of 76 centimeters. Therefore, value of u is 14 centimeters. The screen is at a position of 40.5 centimeters. Therefore, value of v is 35.5 centimeters. Now, knowing the values of u and v, we calculate the focal length of the convex lens using the formula f is equal to uv by u plus v. For more observations, we repeat the same procedure for different values of u and v and record the values in the observation table.
Lens displacement method or conjugate foci method. In lens displacement method, the object, that is the illuminated crosswise, is placed on one end of the optical bench and the screen is placed on the other end of the optical bench. Here, the distance between the object and the screen is L. We need to make sure that the L is 4 times greater than the rough focal length of the lens. Now, place the lens very close to the object and then slowly move it towards the screen until a clear and magnified image is formed on the screen. Note this position as D1. After that, we further move the lens towards the screen until a diminished clear image forms on the screen. Note this position as D2. The displacement of the lens D is given by the difference between D1 and D2, and focal length is given by the formula f is equal to L square minus D square by 4L centimeters, where L is the distance between object and the screen and D is the lens displacement. For an object distance of u 14 centimeters, the value of 1 by u is 0.071. The image distance v is 35.5 centimeters. The value of 1 by v is 0.028 and its corresponding focal length is 10.04 centimeters. Similarly, the readings for different values of u are: average value of f is equal to f1 plus f2 plus f3 plus f4 plus f5 divided by 5, which is 10.04 centimeters. Therefore, the focal length of the convex lens by UV method is 10.04 centimeter and the focal length of the convex lens by distant object method is 10.5 centimeters.
Using the values of u and v from the observation table, we plot u versus v graph and 1 by u versus 1 by v graph, and then we calculate the focal length from these graphs.
Now, we plot a UV graph by considering the value of u on x-axis and the value of v on y-axis. The graph comes out to be a rectangular hyperbola. A line drawn at an angle 45 degrees to both x and y axis meets the rectangular hyperbola at A. AC and AB are perpendiculars drawn onto both axes. The values of AB and AC are same, each being equal to 2f. Therefore, f is equal to OB plus OC by 4, which is 21 plus 21 by 4. Therefore, f is equal to 10.5 centimeters. Focal length of the convex lens from U versus V graph f is equal to 10.5 centimeters. Now, we plot another graph, that is 1 by U versus 1 by V, by considering 1 by U on x-axis and 1 by V on y-axis. The graph comes out to be a straight line cutting the axes at A and B. Therefore, f is equal to 2 by OA plus OB, which is 2 divided by 0.100 plus 0.100. Therefore, f is equal to 10 centimeters. Focal length of the convex lens from 1 by U versus 1 by V graph is 10 centimeters. Precautions. The distance of the object should be more than the focal length. Readings should be taken without any parallax error. The lens should be vertical in the V stand. The center of the convex lens, the screen and the object should be along the same horizontal line.
Now you are able to determine focal length of any given convex lens by distant object method and UV method without any doubt or hesitation. Thank you for watching this video.